Okay, so here we're going to be looking at graphing half conics. I am going to highly recommend having that since you have seen some of these done in class, since we've done them in notes and we've practiced them, that you pause the video, give one a shot, restart the video when you are ready or stuck, whichever one happens to be the case, and that way you can check your work / get help with wherever you are stuck. But don't just watch me do it on the video, right? That doesn't give you that gauge of what you are or are not understanding. And ultimately speaking, you do want to leave this time better prepared to do the problems yourselves, right? So pause the video, give it a shot on your own. Okay, so we're going to do number 1 first here. Okay, so we've got some steps off to the side here just to remind ourselves of how we do a half conic. We start by making sure that we've put the equation into its descriptive form. And we do that by squaring both sides, and then we rearrange the terms however we need to in order to be able to see better either the parabola, the circle, the ellipse, or the hyperbola that is contained within this half conic. Okay, so first up, we are going to square both sides. Squaring x is going to be x squared. Squaring the negative is going to cancel the negative, right? Negative times a negative is a positive. And squaring the square root is going to cancel the square root, so we have 4 minus y squared. And already we know this isn't a parabola because I have 2 squared components. Okay? So then if I add this y squared over to the other side, we get x squared plus y squared equals 4, which is in the form of a circle. And so in this case, I know the center of my circle is going to be at 0, 0. So I can see that here, 0, 0. And my radius, which is, this is r squared back here for a circle, my radius would be 2 squared. And well, sorry, my radius would be 2. This would be 2 squared, so therefore my radius is 2. And so if I were to graph that, my center would be here at 0, 0, and my radius would be 2 in all directions. Now, if we were graphing the circle, I would now connect those 4 points and I'd be good to go. But this is a half conic, so we are only looking at half the circle being kept here. And for that, we need to go back to our original equation, and we need to analyze that original problem to determine which half of the conic is actually being kept. In this particular case, this is an x equals half conic, so we're thinking probably left or right, because that's the x values versus up and down, which are the y values. So left and right here. And in this case, it's x equals negative. And so the question would be, well, where would x equals negative be? That would be on the left-hand side here. Now, I always recommend before you say for sure, like that's my answer, I know what you have to write, take a moment and one of the points that you have excluded, stating that it's not actually a solution, take one of the points that you've excluded, plug it into that original function, make sure it's actually false. Because if you do for some reason plug it in and it ends up being true, then you know that this point that you've excluded actually should be connected to my graph, and it's a good way of double checking you didn't miss something. So if I were to take this 2, 0 and plug it in, 2 would be going into the x, negative root 4 minus 0 squared, which is 2 equals negative root 4, which is 2 equals negative 2, which is a false statement. And so I know that that's not included. Great, I'm good to go. Okay, so it's a good way of just double checking. Okay, number 2 is up next. Okay, take a look at number 2. So same thing, we're going to put this equation into descriptive form, squaring both sides. X squared would be, well, x squared. And on the other side, squaring that square root would cancel the square root, and we'd have y minus 1. And so I know this is a parabola. I'm going to go ahead and flip this equation around. Y minus 1 equals x squared, just because I like this form a little bit better myself. And so then we can pull out our vertex. Our vertex is at 0 for the x, 1 for my y. And then my additional points, so if I were to plug in a couple of additional coordinate points here, maybe plugging in 1 for my x and 2 for my x or something like that. Plugging 1 in for my x, I'd have 1. Adding the 1 over would be 2. Plugging 2 in for my x, I'd have 4. Adding 1 over, I'd have 5 for my y. And so those are two additional points here that I can use, and I can reflect across my line of symmetry to get my parabola shape. Okay, so the same thing, we need to look at that original problem, determine which half conic is going to be kept here. And so looking at this, I noticed that my original problem is an x equals, so I know I'm keeping right or left. And in this particular case, this is x equals a positive. So we have to figure out, well, which side, left or right, would x be positive on? And that would be right. And so we're keeping this side here. And again, I always recommend checking just to be sure. You just, for example, excluded the point -1, 2. And so if I plugged -1, 2 into my function there, -1, 2, I get that -1 equals √1, which is -1 equals 1, which is not true. That is a false statement. And so I'm glad I didn't include that point. Again, if it had ended up being true, I would have wanted to go back and change what I shaded. Okay. Okay, number 3 is up next. Again, a reminder that if you are not pausing the video, you should be giving it a shot on your own or restarting when you are either stuck or have an answer. Okay, so number 3, turning this into descriptive form, squaring both sides. If I square the y, I get y squared. Squaring the negative, negative times the negative is a positive, so the negative goes away. And squaring the square root would go away, so we'd have 16 minus 4x squared. Okay. Adding that 4x squared over, we have 4x squared plus y squared equals 16. And so then dividing that 16, we have x squared over 4 plus y squared over 16 equals 1. And I know this is an ellipse. Well, half ellipse technically speaking, but ellipse is the conic from which my half conic comes from. Okay, so center for my ellipse is at 0, 0. My x radius is 2. My y radius is 4. And then we have to figure out, well, which part of this am I keeping? Well, this is a y equals conic, so I'm thinking, or half conic, so I'm thinking top or bottom. In this case, it's y equals negative, so the question is top or bottom, which one has y be negative? And in this particular case, it would be the bottom. And so I'm keeping this part of my conic right here. Okay. Again, checking our unused point just to make sure. In this particular case, I decided to not keep 0, 4, so I'm going to go ahead and plug in 0, 4. So we have 4 equals negative root 16 minus 4 times 0 squared, which is 4 equals negative root 16, which is 4 equals negative 4, which is a false statement, and so that point shouldn't be included. So we're good to go. Okay, and number 4, last but not least, we've got our y equals root x squared minus 9. Okay. So, squaring both sides, we have y squared equals, and then squaring the square root, it would cancel, so we're at x squared minus 9. Okay, subtracting the x squared over, we are at y squared minus x squared equals negative 9. And then dividing the negative 9, this would be, so now dividing the negative 9, my x now is going to become the positive piece, because negative divided by negative is positive, so we have x squared over 9. And the y squared is going to become the negative piece, y squared over 9. And this is a hyperbola, or a half hyperbola. Okay, so my center is at 0, 0. And then my delta x is 3. My delta y is 3. And I've got my little box with the ability to do my asymptotes. In this particular case, this function leads off with an x, because we have our x squared minus 9 minus y squared minus 9. And so I know as I complete my box and my asymptotes here that my hyperbola is going to be a left-right facing hyperbola. And you want to be careful, especially with the hyperbolas, that you are careful to not look at the half conic to figure out which way you are facing. This tells us which part of the conic I keep. But this is my conic itself, and so this is where I want to look to make sure that I get correctly oriented. This is an x-oriented hyperbola, so we're looking at this guy here. Okay? And normally this would go all the way down, but here's where your half conic comes in. This is a y equals a positive. So we're looking at y equals up, down. Positive means up. That's why I'm just keeping the upper part of this hyperbola. Same on this side. It's going to come down. And again, we'd usually keep going, but we're going to stop there. And I still recommend checking. Now this one's going to be a little bit weirder to check, because I didn't actually find any of these other points, and so I don't have a coordinate point that I left off. And so I always use kind of representative ones for what I'm checking here. So I left out the points for when x is positive, but y is negative. And we're talking positive bigger than 3 and negative. X positive bigger than 3, y negative. And so if I were to plug a negative number, because that's the y that I left out down here, a negative something into that y, and this x is a positive number bigger than 3, so we're looking at greater than what is this, greater than 9, because that's bigger than 3, so 3 squared would be 9, so it's got to be bigger than 9, minus 9. This here is some negative number that's going to equal some positive number, which is a false statement, and so it is good that I left off this bottom portion of my hyperbola. It would generate false statements. Okay? And that's objective 2.